The last topic in section 4.3 is a span. Now, what exactly is span? Well, here we go. Let S be a set of vectors, and then the set of all linear combinations of those vectors is called the span. So, because I think they're kind of the easiest to understand, let me start with my two pseudo examples first. So, what would you say that every color on your iPhone screen is made up of the span of R, G, and B? I think I said that wrong here. We would say, not what would you say. RGB, if you zoom in on your phone, usually I'm in class, I use one of the little projector thingies, and you can see that they're made of little red, green, and blue lights down way in there. And so every single color on your screen is made up out of these things. So all the colors that your screen can make are these in the span of the red, green, and blue lights. Okay. The next one is that most common breads are in the span of these ingredients. Okay, so all these ingredients, you mix those, some linear combinations up of those, and it's the span. Okay, so here we go. Let's do some mathier ones here. Show that R2 is the span of E1 and E2. Okay, so what are we going to do? What are all the linear combinations? Let's say A times E1 plus B times E2. Let's put little vectors here. That makes A times 1, 0 plus B times 0, 1, which is A0 plus 0B, which is AB. Well, look at that. If I want to make any vector, say, I don't know, 7, 3, what's that going to be? That's going to be 7 of the E1 vector plus 3 of the E2 vector. So any vector that I want to make, I can make very easily out of these two vectors. So R2 is the span of those two vectors. What about example 151 here? What is the span of the vectors 1, 1, and 1, minus 1? Now, there's not just one way to think about this, so let's go through it this way, and I can think of a few more ways to explain this also. So both of these vectors are vectors in R2. So I'm just going to say let x, y be some other vector in R2. All right, let's see which x's and y's we can make out of these two. So I'm going to turn everything to matrices because it makes it better. So A vector 1, 1 plus B times the vector 1, negative 1 equals the vector x, y. Again, this is not the only way to think about this. And this makes the system 1, 1x and 1 minus 1y. And I'm going to row reduce this thing. So if I add, let's see, row 1 plus row 2, put that in row 2. If I add row 1 to row 2, I get 1, 1x and 2, 0x plus y. Again, this is why this is helpful to know, even if you're going to use your calculator to do it most of the time. Okay, so that's pretty nice there. I probably should have added row 2 to row 1, but in any case, let's do this now. Let's go switch them, and I'm going to divide by 2 while I'm at it. So I'm going to do 2 at once here. So 1, 0, 1 half x plus y. I know that was 2 different row operations. That's okay. And then we'll go minus R1 plus R2. And that will give me 1, 0, 1 half x plus y. And then if I do negative 1, it kills that. Gives me 1 there. And let's think through this. So negative 1 half x and negative 1 half y plus a whole x leaves me with negative a half x and y. Oops, no, this needs to be positive. So 1 half positive x and a negative y. There we go, sorry. Okay. So what does this actually say? This gives me a unique value for A, which is x plus y over 2, and a unique value for B, which is x minus y over 2. So which can I make? Well, the answer is any of them, right? You pick any x and y, then the value a and the b will give you this linear combination of these two vectors will give you that x and y that you want. Okay, so pick x equals 10 and y equals 3. Then a is going to be 13 over 2, and I've already forgot what numbers I said. B is going to be 7 over 2, right? And that is the linear combination that gives you this thing. And so what is the span? The span of these two vectors is all of R2, okay? Now we should just kind of make a note here that these two vectors span R2 and these two vectors span R2, okay? It's not unique, the spanning set, okay? And just to go back up here, the RGB thing from before, this is what it is in TV land. But as a kindergartner, we all learned that the primary colors were red, yellow, and blue. So somehow here are two different kinds of color schemes in which you can make all the colors out of. And there's a fancy word for this. I can't remember, maybe constructive and destructive, but again, I don't really know how you get yellow out of those two, but maybe one of you can tell me. Okay. To the next example. What is the span of 1, 1, 1 minus 1, and 2, 0? And I have a very specific point about this. These two vectors already spanned R2. Now, by adding a third vector, do I somehow increase the span? Well, if we think of RGB, what if I added yellow? Have I added anything to that? And the answer is no. I already could do everything out of these three. I don't need this one. So adding it really is just extra, okay? And so do I get any more vectors by adding 2, 0? And the answer is no. I don't get any new vectors. The first two things already spanned R2. It can't span R3. My vectors already live in R2. Right? I don't get to go to the bigger land just because I have one more, right? That actually changes who the vectors are. So this still, the span is R2, okay? So I have added a vector that does nothing for me. I have only added a superfluous vector, right? Just one that's extra. Okay. So all in all, what I'm trying to get across is the span of two vectors is all the things that you can make out of those two vectors. To kind of go back to examples earlier and to Calc 3, if we have a plane in R3, that plane is determined by two vectors, right? And with two vectors, you can think of all the ways in which you can add these two vectors, right? You can add those to make all these vectors. Anything that's in that plane that these two things share is going to be the span of those two vectors, which is why the plane determined by two vectors, which is why I only need two vectors to determine a plane, okay? And that plane is spanned by those vectors, okay? All right, we're going to move on to the next section next, and I'll see you then.